Matilda is just 3 weeks old, but she was born 16 weeks too soon. Every year in Australia, more than 18,000 babies like Matilda are born prematurely. Most of these babies only survive because they are given a hormone, synthetic cortisol, before birth. It protects their brains and matures their lungs so they can breathe. Over the past 25 years, a single course of synthetic cortisol has saved thousands of babies' lives. But in half of all Australian hospitals, it's now become normal practice to give more than one course, even though there's no scientific evidence that it helps.
We know that a single course of synthetic cortisol given to women before early preterm birth profoundly improves the outcome. It saves babies' lives, it saves babies' brains. The question now is how many courses should we continue to give if after the first course the woman has not delivered and the risk of early birth continues or occurs.
To find out, Professor Newnham looked at sheep, the best animal model for human pregnancy. He and neuroscientist Lynn Beasley found that giving repeated doses of cortisol had a negative effect on newborn lambs.
We found that it did improve the lungs even more than a single course had, but it also had some deleterious effects which we were not expecting to find.
When the lambs were born, it was immediately obvious which ones had repeated doses of cortisol and which had not.
Well, as you can see, this little one that I'm holding is considerably smaller than the one that Tim is holding. This little lamb, they're both now 2.5 weeks of age. This little one was exposed to stress hormones by the mother having been injected with synthetic cortisol about 2/3 of the way through pregnancy. The mother received 4 doses, and this one that Tim's holding is what we call a control animal. This one, the mother was just injected with saline, just salty water, the same number of times as a comparison. And what we now need to see is whether it's not just a matter of them being smaller at this age, this one and its friends, but whether it's exposed to other risks during adult life.
Small lambs born of malnourished mothers go on to have serious health problems in adult life. The question is, when a lamb is born smaller as a result of multiple doses of cortisol, will it suffer the same effect? Professor Newnham will study the lambs for the next 2 years to find out. But if they do, then the same could be happening in humans.
Well, the sheep is an excellent model for human pregnancy. In fact, much of what we know about unborn babies is in fact sheep, not humans. We know the areas in which sheep are similar to humans, we know the areas in which they're different. In some things like maturation, they're very, very similar. And so sheep give us a lot of the answers that we need to improve clinical practice in humans.
Cortisol works most powerfully on the brain, so Beasley's team looked there and found something quite startling. Dr. Sarah Dunlop first studied the nerve fibres that connect brain cells, fibres that need to be well insulated.
Nerve fibres need to become insulated so that they fire at fast enough conduction velocities so that the brain will actually work.
The first part of the brain she looked at was the optic nerve, and this is what she saw. The nerve fibres of preterm lambs which received no cortisol were well on their way to being insulated, a process known as myelination. The insulation shows up as distinct black rings. Where preterm lambs had only a single course, insulation was not much different. But for lambs which received repeated courses, insulation of the nerve fibres was severely reduced and considerably thinner.
The myelination was delayed, so instead of having about 70% of fibres being myelinated at this stage, only 30% were. And it really looked as if the whole process had been brought to a sudden halt.
However, when they let the lambs who had received multiple doses develop to full term, the insulation of the nerve fibres caught up. But when they looked at brain size, they found that recovery was not so complete. After repeated courses of cortisol, the lamb's brain at term was much smaller, about 20% smaller.
So there's a break on here, and we obviously wanted to know what was happening. Is it that you just have a miniaturized version of a perfect brain, or as a result of having this drug treatment, is something missing? Are some of the cells missing? Is the myelination delayed in other areas?
Then they looked at the corpus callosum. In humans, it contains 300 million nerve fibers through which the two halves of the brain communicate. At term, the insulation of these nerve fibers in the multiple dose lambs was severely delayed, and the corpus callosum was slightly swollen, suggesting the blood-brain barrier was breaking down. It may be that, like the optic nerve, the corpus callosum catches up over time. In sheep, it's not fully developed until they're 2 years old. In humans, not until we're 10. The work in sheep may be cause for concern. But is there any evidence that repeated doses have had any negative effect on children?
What we're going to do is I'm going to show you 2 beads, and you have to look very carefully at those beads, because then I'm going to take them away, and then I want you to point to the picture to show the beads that I have just shown you.
Henry is part of a long-term study following up the development of all children who were born very premature in Western Australia in 1992.
Good fellow, I couldn't trick you. You're just fantastic, aren't you?
More than 700 children are taking part. 10% of them had repeated courses of synthetic cortisol. The study is looking for any sign that this has had an impact on their intellectual development and behaviour. Henry's test shows no problems. He's passed with flying colours. But overall, the study does show evidence for concern. Dr. Noel French has been following the children for the past 6 years. Data so far analysed suggests that multiple doses of synthetic cortisol do make a difference.
They tended to be more busy, overactive, more concentration problems, and that of course raises the issue of potential later learning difficulties related to concentration span problems as they get older. That's clearly something we'll be looking at as they enter school.
Often in science there are no easy answers. To really know what the best dosage is, or whether it has any harmful effect over the long term, you need to conduct human trials.
Dr. Caroline Crowe, one of the obstetricians.
And that's just what's been done in Australia. Researchers in Adelaide are coordinating a national 3-year study, the first ever, that will eventually involve 1,000 women.
What we have is a printed leaflet describing the study to you, which is looking at the role of repeat dose of steroids for women like yourself who may well be likely to deliver very early. Yeah.
When a woman is in danger of delivering prematurely, she is given a single course of synthetic cortisol. That's standard. But if the baby hasn't been born a week later, often she would be given a repeat course. In this study, though, only half of these mothers will get cortisol. The other half will get a placebo instead.
It is the only way that we can move forward to get strong evidence as to whether a treatment is beneficial or not. It's the gold standard research methodology to assess whether a drug therapy is actually helpful or not.
If questions have been raised about the safety of multiple courses of cortisol, at least in sheep, shouldn't we just stop the practice in humans?
The sheep work hasn't proven what exactly happens in humans. So at the present time, it's been standard practice to give repeated doses in 50% of obstetric hospitals. It's been standard practice in another 50% to not give repeated doses. So it's entirely ethical to trial these 2 protocols.
Doctors are still recruiting women for the trial, so it will take at least 3 years to see a result. It will be 2 years before the sheep studies provide some answers about the long-term effects on the brain and health.
Be looking at getting him extubated by the weekend, I'd say.
The question mark is over multiple courses of synthetic cortisol, not the use of cortisol itself. In trying to save babies' lives, medical practice has moved ahead of what science had shown was safe. Now medicine has to wait for science to catch up.